So anybody that came in late, nobody happens to have a Mac adapter, do they? Because this is going to be a very clunky show. I've got video within the thing, but it doesn't start up, so it'll just provide like lots of opportunity to ask questions while I turn off the slideshow, drag video across. Okay, great. That'd be awesome. I mean, I can go ahead and get started, and if he comes back with that, we can take a short break and switch over because it'll go smoother. Although it won't be terrible.
Or we could wait like 5 minutes and then, what do you want to do?
It doesn't matter. I mean, I can just do a brief intro to this talk. Is just for anybody that's already using Amazon Web Services, it's probably going to be boring. It's really just an introduction. There's a bunch of acronyms that are within the landscape that it's just an introduction to, and it's just intended to show you how easy it is to get started with kind of cloud-based infrastructure with Amazon, just because it just takes a credit card. They've got a lot of free tier options, and you can get a LAMP stack going pretty quickly, and actually take advantage of a lot of their web services pretty quickly. And of course, there's good PHP SDK wrappers around all their APIs. Some of the things that you can do with the services aren't even available through the normal GUI interface. You'd have to use the API to do it. But so that's kind of the general idea of this, in case anybody was thinking it was something else. I don't know. I'll stop even there. Any questions about that so far? Was it about what you thought it would be different? Anybody here using Amazon for just a little bit?
I got the free tier and I've been playing around with it.
Yeah. All right. Anybody using something else?
Backspace? I've used both actually.
Yeah.
I'm going to use
Or
that
I'm
as
using both.
to host a few things.
Okay. Some of the independent services you can use piecemeal, or obviously they work pretty well together, but they continue to add to their suite. So certainly there's a lot of other players in the market. I think Amazon's been at it for a while. They just sort of expose what they use for their own e-commerce platform. So it makes it pretty nice in there. They get a good head start. I can't say in terms of comparing them to other services.
What is it called again?
What's what?
The service called?
Oh, just Amazon Web Services. It's the whole. It's the EC2 and Elastic Load Balancers and message queuing and email services.
RDS?
Yes, relational database services.
S3.
Whole bunch of S3, yes, for storage. Elastic volumes.
What's the monitoring one?
What's what?
The monitor, I can't say the word now. Monitoring?
Oh, monitoring,
Yes.
CloudWatch.
CloudWatch.
Yes, there's no services that will monitor your instances, which we'll touch on all that. I mean, this is it's just a brief overview, so it certainly is a lot deeper than what we'll go into today. But the intention is that really, if you just if you've got an Amazon account, you can basically get going with this stuff pretty easily, and it's pretty fun if you haven't kind of considered hardware as software. Okay, cool. Hopefully that'll play nice. All right. So I basically gave you an intro to me. That's my name, Jeff Wineset. About 15 years or so consulting, and a lot of that consulting work was done with startups and even some that was non-consulting work was in startups. Currently, I work at a crazy company that focuses on women's hair. If you want to ask me more about that later, I'm happy to talk more about it. And I do have kind of an LLC that sort of continue to do services consulting at Seesaw Labs here in town now. So the goal, man, this is really hard to say. I think I want to just as I mentioned, is really just to put some color to some of these acronyms. I think as you're kind of diving into the whole landscape of Amazon Web Services, it can be a little daunting at first, just because there's a lot of services that they offer, a lot of ways that you can stitch these together for your needs. But it's just to provide a basic comfort level so that you can get started. So obviously the cloud, people have overused the word. It's been a joke for years now. It's just hardly even interesting to talk about much anymore, but just so that we're clear as we're going through and what I mean today by the cloud. So cloud can kind of mean any sort of set of delivered hosted services over the internet. So there's, if you take a look at the infrastructure as a service, which is where we're going to be focused today, Amazon Web Services, certainly Rackspace, and there's others in the field. There's platform as a service, so Google App Engine and Heroku and PHP Fog and those kind of platform as a services provide you. It's almost like a tier on top of that are providing you more of an interface to sort of launch your apps in. And then there's software as a service. People know Google Apps and your 37 Signal suite and all the good stuff that you use probably day to day for issue tracking and well, any other sort of software as a service. But today we're going to be focused on the first, infrastructure as a service. So that's really what we're going to be talking about in terms of cloud. So why should you care? So I've got it kind of broken down between whether you carry a briefcase or not. So from the business perspective, there's really minimal upfront infrastructure investment. So when you're moving into an infrastructure as a service solution, there's no racks to worry about or power supplies, certainly any of those things like actual physical hardware, load balancers, all those kind of things that you don't have to worry about investing in. Just-in-time infrastructure, so this is all around being able to, say goodbye to the days where if you were starting something up or just getting going, that you could be the victim of your own success if you got popular real quick and people would hammer you with traffic because you didn't have the money to put together this super robust infrastructure to support that. And really, so are the days of where you can fall victim to your own failure because maybe you did overinvest in a bunch of hardware thinking that bright idea was super awesome and it turned out not to be, and you're left holding the bag on thousands and thousands and thousands of dollars if you set it up in a traditional way. So in this case, what it offers is it just scales as you do. More efficient resource utilization. So in this case, system admins don't have to worry about underutilized systems or overutilized systems and trying to get more resources. You can spin stuff up as you need. And then the pay-as-you-use model is also part of kind of the elastic nature of the cloud so that you can really you're just paying for what you need, but it's also nice in the sense that as you're building out your application, say it's not performing super awesome for whatever reason, and you decide, well, one solution is just toss more hardware at it, which is fine. You can do that. You can spin that up. But then if you, a couple weeks later, a couple months later, whatever it takes, you find, a caching layer is going to really improve my performance here, and I actually don't need 6 megaboxes to support my application because I can just put this read-through caching tier on. Then you spin those down, you don't pay for them anymore. It goes up and down as your resource needs demand. So you're probably saying, I don't carry a briefcase, so why should I care? So from a technical aspect, there's the automation. So it's this, in terms of the scriptable infrastructure, you can automatically build environments and spin stuff up and spin stuff down, and it kind of goes into the auto scaling aspects, which allow you to script both scaling up and scaling down your infrastructure as needed, kind of on demand based on traffic patterns. Proactive scaling, so this would be more about being able to scale up or scale down on certain schedule basis. So if you know your traffic dies down at night, or maybe you have an application that just no one uses outside of 9 to 5, you can turn the stuff off from 5 to 9. Or say you've got that Super Bowl moment, or you're going to be on the Today Show, or whatever the case might be, and you know from a marketing perspective you need to scale stuff up, you can take that proactive measure and do that in those moments. Certainly an efficient development lifecycle and improved testability. So, it can be hard to replicate your production environment in times, sometimes because there's a cost preventing that, or just access to the resources to be able to mirror your production environment, or spin up a bunch of servers because you want to do load testing, or whatever the case may be. So it really allows you to not have to worry about not having the same environment for development or QA or staging. You can easily mirror that and then turn it back off if not needed for the testing and whatever your development lifecycle happens to be in terms of pushing stuff from bright ideas to production environment. And then from the disaster recovery aspect, so it starts to really provide, again, a very cost-effective way, a way to build out replicated instances across different regions so that you're able to have quick, disaster recovery in case something were to fail. AWS offers both region and availability zones, which we'll get into briefly, but it allows you to kind of mirror your environments pretty easily in disparate geographical locations. All right, so we're going to get into how it's done. Really, as I mentioned, you need to know how to get to Amazon.com and your favorite browser and have a credit card. So it's aws.amazon.com, the login, don't have to look at it too much, and then you're off to kind of a dashboard, which I think this has actually been changed since this was made, but all the same services are there. So again, you've got this laundry list of services. These keep growing and they can get a little bit daunting, but EC2 is where we're going to start out because it is, it's the elastic cloud compute, which is like your server. Just think of it like that's your server in the cloud. And so it's a question and answer format. So how do we want to meet our LAMP stack environment needs to run those kick-ass applications and websites? Well, EC2 is the place to start for sure because it's going to provide the basic unit for the LAMP stack. So what is EC2? It's the server instances, as I mentioned. Just think of them as computers basically, and it is a service that it does provide the resizable compute capacity. So they're not fixed servers. They are flexible. They are elastic. You can change their configurations very easily with clicks of a button and ticks of combo buttons. So, the why here is pretty straightforward. You're going to be running an application. You definitely need a place to run it, and it's got to have a software to run it. So how to get started? Really, before jumping in and launching a new EC2 instance, there's a couple things you have to do in advance just to be able to connect to it. So you first start off creating a key pair, and it controls the SSH access to your EC2 instances. And basically what happens is you download the private side, and when it spins up, when you ask it to spin up, it'll put the public side on it, and it'll compare those two when you log in through SSH. So to do so, hopefully this will just kick off, good. So in the dashboard, again, we're back in, we're logged in, we go to EC2, and we go over on the left, network and security, and we're looking at the key pairs. You click the create key pair button. It's certainly good to rotate these every now and then from a security standpoint. So, a decent practice is to name it in terms of your development that you want this in. The environment, which in case we're just creating like a development box. And then, if you're going to cycle it yearly, at least know the year that you created that thing. And so what happened there is it downloaded the PIM, which is the private side of the key. And it'll know based on your account that when you spin up instances, it'll deliver that the public side to a specific user, EC2 users, home directories that you can get into. The other thing that we kind of need to configure before we launch a new instance, so that was all there is to, that's not all there is. There's potentially more to learn about key value pairs, I mean key security pairs, but and just in terms to get started, that's all you really need to do. You just need to set one up and be able to access that private sign when you're going to SSH in the box. Security groups are a way to configure the network firewalls for the boxes, and they control the TCP and sort of UDP port level access. And they're assigned to instances when they're created, so you choose your security group that you want to assign to the box. It's also good to have these sort of for each environment and make sure that based on your environments that they're good and locked down to just the ports or the IP addresses that you want them to be. But it's also a good practice. They've got some default settings that you can choose, but I just find it's nicer if you just set these up so that you know exactly what your security are for each of these, and you can choose them as you're launching instances because you'll be doing it pretty frequently. Launching instances, that is, if you're using this suite of services. So to do that, go back into EC2, and we'll be back over on the left-hand side under Network and Security. There's the security groups link. And in this case, like I mentioned, there's a default one. We're just going to create our new security group here so that we know exactly what ports are set up that we need. And we'll give it the same name as the environment. Again, we're calling it a development environment. And whatever you want to call it in terms of name description. And the VPC is a virtual private cloud, and it's not what we're going to be talking about today. We're just talking about normal instances in the cloud. VPC is something we can look into maybe at a different group discussion. So to configure the rules, you basically choose the group that you have and go down to the tabs down there for the inbound rules. And so we're going to allow HTTP and HTTPS access basically from anywhere, just that we can get our website running on this box. And we'll also allow SSH, and I think I've shown it here as allowing it also from anywhere. That's obviously up to you and your security concerns as to whether you want SSH access from anywhere, but for the sake of this, showing this example, it's fine, or quickly accessing it. But you could put in your own IP address and route number there. So I think that's it. Unfortunately, these things do not end in a nice blank screen like I had set them up, so I kind of never know what to do. So we're still on the EC2, how do you do it? So what we've done is created the key pair, so we can access the box through SSH, the security group, so that we can configure the firewall and make sure that nobody's getting in that we don't want in. And now we can finally launch our instance. So once again, we're back to our old friend EC2, and in this case, we're going to launch the instance. There's a couple different wizards that they allow you to choose from. Obviously, the more you use it, the more you can configure your own GUI environment. We've got a lot of different underlying OSs that you can choose from. In my experience, I found that the Amazon Linux AMI is fine. It's like a Red Hat Enterprise Linux, somewhere between 5 and 6 with a little CentOS flavor. It's its own flavor, but it works great, and it obviously works well with their suite of services. And you can choose the size of the instance. So we talked about the instance being elastic. In this case, the micro is what we're choosing because it's free. It's a free tier at least for a year when you sign up, but it goes all the way up to just huge sort of sized boxes, and they have you can find on the website like how these compare to like normal sized boxes. If you have existing physical infrastructure and you want to try to map to EC2 instances, it's not going to be one-to-one, but you'll be able to find the same sort of CPU cycles and memory usage and that kind of stuff, or memory capacity. So the other thing too, I think I was on there, was the Cloud Watch, which you can click on if you want. There's extra fees if you want to do that. You can do that later as well. You don't have to choose all that now. These key value pairs are just, I think you can do up to 10 of them or so, allow you to just attach extra metadata. It's really for your own categories. In this case, I'm giving it a name, which is I'm calling it the environment, and I'm giving it a date and a time. Although I could separate out date as a key and the value of date and time as a key and time being a value. These are just for your own needs, and this is basically for your own administration. we're choosing the key pair that we created in the first video or the couple slides back, and choosing the security group. You can also do it right there, so you can see through this wizard, you could have created the security group right then and there as well. But basically, you get the chance to review it, and click launch, and it will kick off what it needs to do to spin this up based on your configuration parameters. And you can just go to the instances tab to see that happening. It'll go through a few, as a little life cycle in terms of its statuses. So it starts off in pending and will eventually be running, but it's still initializing. It's got a few status checks that it likes to check to make sure that everything's okay. Yes?
Those instances, they have root access to those instances?
Yeah, through the SSH, that's right. When you log in as EC2-user with the PIM that you downloaded for the first, you have sudo access.
Okay. That's cool.
So just going through those tabs, there's the monitoring there. Again, you can enable the CloudWatch later, and that's just a deeper monitoring for these boxes that give you, what you can see there behind the veil, the CPU utilization and disk utilization, and other kind of dashboard metrics on how that box is doing. And under that tags tab, which we didn't, just list those 10, up to 10 key value pairs that you might have associated with an instance. Should I stop there? Is there questions from anyone?
Does it have FTP access that you can create, or?
Yeah, once you can get on the box, you can access, and you can set it up through the security group if you want to control it there. But you can do anything you want, on the box once you get access to it.
Well, if you have SSH access, then you can SFTP into it, right?
You can, yep, an SCP. You can do some other things on
So
the
as far as
security.
package management and all that is traditional, the same way as if you had your own?
Yes, it's all the same.
Well, so you can only you still need to authenticate using the key value pair. So in FileZilla, you have to add the key to your thing, but once you do, then you can connect with FTP or FTP programs.
Right. I mean, I suppose I'm sure that's right from starting off. I mean, once you're on the box and you can create other users, you can create other passwords. You can just say such and such protocols wide open. So I don't think it's limiting. It's not limiting you in any way to however you want to set up your protocols and access to the box.
Is the firewall just external access, or does that protect you from other EC2 instances?
I've only used it from external access, but your EC2 instances, which we'll talk about in a minute, you can associate with elastic IPs which are fixed, and so they'll have a fixed, and they'll have they have a fixed internal IP, although the internal IP probably changes as you spin it up and spin it down. But I'm not sure. You mean you just want to keep other instances out from talking to it?
Yeah.
My guess is that you could use that security group to do that.
I was just curious if it was managing your stuff as private to, all of your EC2 instances can talk to each other, but.
You can definitely configure it that way, and I think certainly that VPC option, the virtual private cloud, probably provides you even more of a way to put together your sort of intranet that's private to your company. But yeah, I'm not 100% sure all the limitations of the firewall, the security group, or what it can do, because I've actually only used it for external access for the different protocols. But I'll tell you, Amazon.com has a wealth of information in their documentation. Okay, so we talked about, great, we've got a few things that we've created, and we've got a box now, so how do we access it? And really just from the command line, at least, assuming that you've made the same choices that we did when running Linux box. You can SSH into it with that EC2-user. That's what the user is when you create that key pair. And in this case, we got that public IP from the description information. Probably should have stopped on that in the video, but all that information when you create an instance will give you, every instance comes with a private and public IP that you can access. And then it's just really a path to that PIM file that you download, and that will get you on the bus. And basically that's what I saw when I logged into this one, which is EC2, and it tells me I already need that to do a security update. Okay, that was EC2, that was that first acronym. So elastic block storage, lots of E's in these acronyms for underscore the elasticity nature of the cloud. So it is the case that when you shut these things down, or when they shut themselves down, which they invariably do, you're basically, anything that's locally stored will go away when you spin stuff back up. And so you definitely want a persistent way to keep at least a subset of your data. Certainly your MySQL data, if you're running MySQL locally. Log files are a good example of your code base. Some other things like that you might want to keep around. So the answer is to keep your elastic block storage, which you could think of in a way as the hard drive. It's a separate sort of entity from the EC2 instance. I mean, you can have local storage, although I think there are instance types that don't even have local storage at all, and micro, I think, is one of those. So it already has. When we launch this, and we'll see it in a minute, it already has an 8 gigabyte elastic block storage mounted to it. That is the underlying, that is the root mount. So
is it creating a virtual machine environment for you? Is that what's really happening?
Well, yes. I mean, in a way, the instance with the EBS, I mean, together, in terms of, combined, you're creating an image, a virtual image from that you can spin up together and always have as, your basic server plus, your underlying OS plus the hard drive for accessing it.
So then if, let's suppose you weren't going to have internet access, could you download your virtual machine and then work with it locally for some reason if you need to do it?
You mean spin it up on your own
Yes.
device from?
I know that goes contrary to the whole idea of cloud computing. I get that, but
I don't know what it would take to get that. The snapshot I don't think is available in that capacity, but I'm not 100% sure. I don't, you mean take the instance as it is?
well, because then the next question would be is if you could take your instance and then say you wanted to move away from Amazon Web Services and go to a different service, could you then re-upload and then preserve all your work as that virtual?
Yeah, it's not, no, I think it's more connected to their services than that. But I think that's a good question. I wonder what they probably don't want you moving to another service with all of that information, but there's definitely, I've never dealt with, the way that you take a snapshot of your stuff and respin up instances is an image, it's an Amazon machine image, but it is not something that I think you're going to find very useful outside of their service suite. But I'm not 100% sure. This stuff changes all the time. Even in the 2 months it's been since I put this together, they've probably had 2 new services come out and different tools and tricks.
As a follow-up to that, are you familiar with any backup software that deals directly maybe with just the elastic block store? So maybe just to piggyback on what you were saying, maybe if you just wanted the data and you already know your configuration for your Linux machine, so if you wanted to move that out, do you know of any backup software or additional software versus I guess maybe just rolling FileZilla and dumping it, but are you familiar with any software like that, or?
Well, certainly for backing up your elastic block stores within the suite of tools, it's dead simple. It's a right click and you take a snapshot, and then you can mount that to any other device you want. The elastic block store and the device itself need to be in the same availability zone, but you can connect them up any way you want. But in terms of you want that data, just you want it back out, and you want to take that snapshot as something that would provide you access to that data instead of mounting it and then just SCPing it or whatever you want to do down locally. Not that I know of, but there are myriad third-party tools that are wrapped around the EC2, sorry, not just EC2, the Amazon Web Services suite that probably, may provide a different format of the snapshot that is allowing you access to that data, perhaps. I mean, I guess what I would do is mount it up and do it the old-fashioned way, which is, push the data, down however you want to do it.
How much different is it than like a shared server?
How much? Well, certainly depending on the instance type and whether or not you're set up to have like reserved instances or not, you basically are shared. I mean, that is why you can be on boxes with other people that are getting hammered, and that's why, and you may be fine, but it can have the same effects as a normal. I mean, it's basically very similar. I mean, it's to a shared environment. You are sharing resources unless you set up your configuration to say, I want to pay for, I don't want anybody else to be in my arena, my server for the most part. You can specify that and pay for it.
Does it get like slowed down though?
Yeah, yes, and it'll come to a complete freezing stop, and you may wonder like, hey, I'm not even doing anything on this application of mine, and all of a sudden I can't SSH into it, things just frozen, it just seems to have gone to the netherworld. Absolutely. And that's a huge and very important thing with working with the cloud, that you must architect in a way that you expect that to happen all the time. And if you do, you're going to be golden. If you know that, because it's so dead simple to just spin up a new one, and and you don't even have to do it because you can automate it, that you've got the right pinging that's going on or the right metrics around your CloudWatch, and you know when that happens, it's just going to take care. It's going to take your AMI snapshot, it's going to rebuild it. It may take a few minutes, but not more than that, and you're off and running again. So it's a really good point that I think people can come to the cloud, especially in the information as a service realm of it, and be very frustrated because it is relatively unstable. And I say relatively just because, it's just variable. You can have, it's been 6 months since I've had to reboot that thing, amazing, and then all of a sudden you have a month where it's 5 times and I have to, spin up stuff. So it's very variable. But you just go into it knowing that that's the deal, and it's almost easier just to take something, throw it in the trash, and start over. Then you're not trying to SSH and wonder what's wrong with it, and let me troubleshoot this. And I mean, you'll have to do that at times when it's application issues or otherwise. But at some point, it's not really your issue. It's just the nature of the environment that you're swimming in, and you just want to, basically just kick it off again.
Is it pretty easy to know like why that's happening while it's happening?
It depends. I mean, I guess it depends on what is it that's happening. Sometimes no, because you try to SSH and you get nothing. You can't get to it. There's no, you can't. Your metrics are just saying 0% CPU utilization. You can't get to it. You're not sure why. You might check Twitter and see if there's like a storm in the Northeast and you happen to be in the Northeast region, which has happened, or some other outage that's kind of known. Amazon offers support, all kinds of different tiers and levels that you can pay for, and so there probably is an option where you could call in and figure that out. But they don't have access to your instances at all, and they don't want it. So they can only help you from a very sort of, abstract way. They can't log onto your box. They can't really help you troubleshoot. There are separate companies that wrap their services around that, where you give them access to your, your infrastructure, and you get their sysadmin help or whatever. That'd be just like having somebody on your team.
Rackspace.
Or like
What's
what
that?
about set mirrors and stuff? You can set up mirrors like around different places.
You can do multi-zone, so that's
So-
what.
Oh,
Drops.
right, mirror the environment. Yes, so that's one quick and easy way that a lot of people, which we'll get to actually, and that just put their instances in different. You can do it in different regions, which are geographically very disparately geographically located, and then availability zones within regions, which are more locally but still physically separate. So think of it like, and 2 availability zones probably wouldn't be hurt by the same fire, but they would the same big storm. Like, it's usually like they're physically separate from isolated occurrences, but they're still in the general same area. They're still in the northeast, in their northeast data center.
So I thought, to go back to the question about the CPU utilization.
Yes.
I thought, when I was looking into it, the major difference from what I remember between Amazon and Rackspace was Rackspace lets you burst, like they give you, like 1.2 cores for the equivalent on Amazon, but you can burst up to more than that. And then Amazon, I thought, was you were locked at whatever number of cores that they give you. Maybe.
Right.
Like,
Yeah,
so
I'm not
like-
aware of it, of their actual, like their computing capacity at that level in terms of the CPU cycles being something I mean, it scales in the sense that you can just create a new instance with
Right.
more
Right.
and create multiple behind a load balancer or whatever. But yeah, I'm not aware that it does that on Amazon. But yeah, that could be a difference, sure. But it's not always that's the problem. I mean, there's just all kinds of other, reasons why.
So like, I guess some like other differences that I remember, since we're talking about EBS, is EBS is not, they basically have a big SAN or, a big rack of drives, and it's not RAID 5, I believe, or maybe it is RAID 5, but it's not as good as the Rackspace. Rackspace does RAID 10, I think, for all their the equivalent of the EBS. So
Right.
they have a little bit better durability in terms of, not losing data.
Right. Yeah, I mean, I haven't, in terms of, as long as, again, I guess it's just, if you're sticking with the mantra of that failure is absolutely part of the equation, and you've got everything good and snapshotted up,
Right.
and can easily spin back up, and you're doing rolling snapshots of those EBS volumes, then, you get less and less fearful of the failure, and more reliant on, you're scripting all your infrastructure to be doing what it needs to do. But yes, I mean, I'm sure Rackspace is finding all kinds of ways to, stay competitive, and
Right.
I'm sure that there's lots of differences in the details. Okay, so I think we've kind of covered why you can stop and start the instance without having to lose your data, easily scale up, and easy backup and replication of your data. So we're going to get into just creating an EBS volume, which is fairly easy, as most of these are. They're kind of point and click things. You go to the Elastic Block Store section on the left, and that's the 8 gigabyte one that we got kind of for free because we started an instance that already had EBS mounted storage. It doesn't even have local storage at all. In this case, I'm creating a 20 gigabyte storage. I do need to put this in the same availability zone as the server I want to mount it on. So I happen to remember that my EC2 instance was in zone D, but you can always just toggle back to that section and look and see where your instance is if you forget. And it goes through a similar kind of life cycle of spinning up and gives you some availability to do some checking on it on the bottom tabs in terms of its details. And then when it's done, you can attach it to an instance in your instances list. In this case, we just have one. And you'll put the mount drive that you're going to set up. I just have already configured or expected to use SDH, but it gives you a range of those drives that you can use. Okay, it's just refreshing to say when it's done. All right, so you've got the okay, then it's attached to that, to the instance.
So you're attaching two EBS to one instance?
That's right, a 20 gigabyte, basically drive to that instance that we created. Everything's not quite done, so you still need to configure your instance to mount drive at that level. This is just an example of using the XFS file system. You don't have to use that. In fact, the ext4 is what it looks like at the root already, and you can just edit the etc FS tab in order to have it mount on reboot time without having to do any installing of XFS. So that's kind of up to your sysadmin desires as to what file system you might want to use to mount it. But it's not any more than a few steps to get that mounted, and basically the dev SDH is what we typed in to the mount point on the EBS volume when we attached it, so we're ensuring that that's the same here. And there's really not much more to it than that. Then you can start accessing it. In this case, I've called it just MNT for mount, and it's just, I just call it data. That's where my data lives. Obviously, that's your choice. That's where you want to put it. And then, so, you know, you have your instance. You've got a 20 gigabyte drive attached to it if you want, or whatever gigabyte you decided you need for your development needs. Obviously, you don't have, if you've started with just a generic flavor of the Amazon AMI, you don't have your other AMP goodies, though there are plenty of publicly available AMIs to choose from that have all this already. So we could have easily just have chosen somebody else's. Because if I do all this, right, and I set it up just like, I like to do it myself because I want to know exactly where my MySQL logs are and my Apache config and everything like that. Well, you can figure that out from somebody else's configuration. But if you get this set up like you like it, you take a snapshot of it, that's basically your AMI, and you can share that. You can just share it with somebody else, and somebody else coming in can just choose Jeff's AMI, and it would just, you wouldn't have to go through these steps. So it would basically save everything that I've configured, all my PHP extensions, anything else that I've got going. So I'm not going to obviously go through that. It'd be painful to show you all. People have probably done that before, but so that's kind of the point of that. So you've got all this time, you've configured it just like you like it, and we want to be able to easily and consistently replicate what we've done kind of over and over. So we created an AMI. So it stands for Amazon Machine Image, and it contains all the info that we need to kind of do this repeatedly. So the AMI are the basic units of deployment. So that is kind of your elastic compute in a way, is your AMI unit, and it allows you to just rapidly boot up instances as you need them. And it's what you would need to start using if you were going to configure that in an automated way. So you'd be dealing with your AMI. Just, you know, it would know exactly when you say, I want to create a new instance, you just say launch instance from this AMI, and it's going to be exactly what it was the last time you took a backup and created an AMI from that instance. So, you know, certainly if you're making any of your changes on your box configuration changes, you'd need to create a new AMI to secure that that's going to be replicated on the next instance that you create from that AMI. And there's all kinds of other configuration tools like Puppet, Chef, and those kind of things that would help you distribute that across multiple servers if you would. Yep, and assist with configuration management. I mean, it's one way to go about it. So in order to do that, you're going to go to your running instances, which we've had. We created an instance. And to create an AMI, you just right-click on it and click the button, Create AMI. And you give it a name, which I usually also like to provide some sense of the date. So I know what my latest one was. If I have multiple, any description you like, it's obviously up to you. Clearly I was typing extremely slowly. The no reboot option is fairly new. It actually allows you to create a snapshot of your setup without rebooting it, so while it's in use. I have heard that that's still a little buggy, and it's best if you can let it reboot in order to make the snapshot. You basically click OK, and you can go back over to your, now you've got on the left-hand side under Images, you've got an AMI tab, and you can basically see anything that's created from there.
So obviously, if you had two web servers or two machines up, then you could, and you had a MagNet job or whatever to create an AMI, right? Like if you bring one down to do that, then it doesn't matter because the other one's up and serving requests.
Yeah, if they're the same box. I mean, you're going to get a snapshot of whichever one you do
Right.
that, but that's right. That's right. And really it depends on what you need, you know, your AMI to be, if you want, if you're really needing it to capture that real-time data that's writing to it, then you probably want to keep doing that. But I wouldn't use it as a persistent way to sort of store that data. You'd use some other, you'd be writing that off to your EBS or something. You wouldn't have to worry about it. It's more like for configuration changes at your docs. So, where are we off to here? Request instances. Oh, so what I was doing, sorry, that was probably, all I was showing you was, now that you've got this AMI that you've created, you can just easily right-click on it and launch an instance from that AMI. And now we've got 2 identical instances created with all that stuff that we did on the configuration to begin with. And it was just however long that took, right? I blinked and missed my own video. And basically now you've got this other instance. It's got a brand new public IP and private IP. And it's basically that easy to the GUI to create a new Amazon instance.
What app did you use to capture that so that you can replay it as a video?
What's that?
What app did you use to capture all your screenshots?
Oh, I think it was ScreenFlow.
ScreenFlow?
Yeah. But there's tons of other options. I think ScreenFlow's a little, I mean, it's maybe like $80 or $90 if you want to pay for the license, but it's got a lot of cool features. I do a lot of screencasts. Use the audio and everything. Okay, so that was really basically showing you now that we had one, it's really easy to replicate manually another one. And of course, all this is scriptable. Every single thing through the GUI has got an API behind it, and the API has a whole lot more than the GUI exposes. So you can see how easy it is to basically just write a script that's basically saying, hey, it's 8 o'clock. Why don't you kill off these servers, leave us with just 4 for the night, and then when we come in the morning, use this AMI and spin up the 4 that we need throughout the day, or whatever your needs are for the application. So EC2 instance IPs, yes.
When you spun up that extra instance, did they now both share the same EBS volume?
No, they
They
have.
have their own. Okay.
Yes, it's exactly a replica of everything. It's got its own 8 gigabyte for its basically its OS layer, its root mount. It's got the 20 gigabyte that we
So
added
it creates
to.
its whole new separate thing.
It's the whole thing.
Okay.
That's right. It's the whole unit. And yeah, you can have, so certainly when your instances go away, you can have sort of these orphan EBS volumes that you will pay for. It's not a huge amount if you don't reattach them. So if you're just accustomed to just always spinning up a new instance that comes with that, you may end up with a bunch that you need to go back and remember to delete. So basically, as I mentioned, each EC2 instance comes with a private and public IP address, and also provided with internal private and public. And you can get those. It's just showing you where those were in that tab down there, were the ones that we created.
Is that a static or a dynamic IP address?
These are dynamic. These are dynamic. So that is that's exactly why we're talking about the elastic IP. That's right. So clearly, if you've got this instance and you're like, great, I'm going to point my DNS to it and use the IP address and map it to my domain and have my website serving, is fine as long as that instance is up. But as soon as you just stop and start it, or if it happens to go away, when you spin it back up or create a new one, you're going to have a brand new IP address. That one will be relinquished back out to the IP pool, and you'll get a brand new one. I mean, I suppose there's a small probability you get the same one back, but very unlikely you'll get the same one back. So you do need a way to keep a static IP address associated with instances from time to time. Although, as we'll see, you can map your domains to a load balancer CNAME, and then that can just hit any number of instances using the internal IP address, and you certainly don't have to have a need for a static IP for every single server that you might be using for your application. So true, if you were to spin it back up, then you're gonna have a sad traffic routing, it'll be routing to some other either dead IP, or it could be somebody else's. I doubt that they're gonna have the same domain name set up in their host file, but we know it's somewhere else. So the answer to this is you want to associate at least some of them with an elastic IP address. So they provide static IP addresses, and they're designed for dynamic cloud computing, and they're associated with your AWS account. So you attach these to instances as you need them, and they stay with you for your account. So I think that's clear. It also just allows you to, there's no waiting on any DNS propagation. So when you've got your DNS map to the right, a record as the case may be, if you're using an IP address, then if something goes wrong, you don't have to muck with any of that. You're just simply attaching a new instance to that IP, and you move on down the road. So to do that, we're back. We're not even getting out of the EC2 tab yet. And the elastic IPs under network and security, allocate new address, and you're telling it that it's going to be using EC2 as opposed to that virtual private cloud that we haven't really talked much about. And this is just allocating it to your account. So it gave us that 5016, 23419. It's not associated with anything other than my account until I associate it. And I'll select one of the instances. We've got the two now set up because we created one from scratch and then one from the AMI. And just click allocate, and it does what it needs to do. So go back into the instances, and we look at the one that we allocated it, and there it is. It's changed now from that longer, more clumsy public IP to that 50.16.234.19. And that's replicated. You can still get to it from that longer name. And I think if I recall, so we're gonna remove it. So you can remove it from being associated with an instance by disassociate. So we'll do that, and we will associate it to the other one. It's just to show you how easy it is to really map an IP address against an instance. And then we're going to go back in and just sort of indicate that indeed happened. So we looked at the other one, which is the first one up there, and then that one gets the static IP that we have, and we look at another one, which we didn't do a good comparison, but this is supposed to show that that's a different one than it was to begin with, and that's part of the problem. It got reallocated. So you spun it up, it had one that it got associated with, you attached your static one to it, it was associated with it. When you disassociate it, then it's going to grab yet another one. It won't be that same one that you had to begin with. It'll be another one that it grabbed. Okay. So while we have two identical instances up, which we do, we should talk quickly about elastic load balancing. So if we want to route traffic to both of these guys that we have them up now, we've basically got them, they're both mirrored applications. They both got our lamp stack on them. If you pushed your code base to them and you configured everything, they got your kick-ass website running on them. So we'd like to distribute traffic to both of them. So that stands for elastic load balancing. Again, another E, and it provides a means to distribute our traffic across multiple EC2 instances. And these can be across availability zones, but they only do work within a single region. So you can't use a single ELB to actually. You have to use more like GeoDNS routing to do that. It won't get you that, but it allows you to do within the availability zone.
Is the presumption that a new instance was created on a different physical server? Because if it's on the same server, you'd be doing yourself a disservice by creating multiple instances on the same server, right?
It's a good question. I don't know how likely it would be that you would end up like if you created two micro instances that you're on the same physical server, but I suppose it's a possibility. Certainly if you've chosen two availability zones, which would always be a pretty decent practice in terms of, if you have an equal number of instances, that you should split them up across availability zones just to give you that extra layer of sort of disaster recovery in case something did happen at a small local level. Or availability zones have their own strange outages. But I suppose there is a likelihood, but I don't know for sure. I actually don't know that you could actually, both of those could be on Although in this case, they're on different availability zones, we chose that to begin with. But if you chose the same availability zone,
Okay.
I suppose, I don't really know the algorithm that they're using to choose where your instance lives. But it would seem reasonable that there's a potential for you to actually be on the same shared physical device, even though you have what are called two distinct micro instances.
So you're saying you can say two different availability zones without guaranteed two different servers?
Absolutely guaranteed.
Okay.
Those are physically separated locations, yeah.
So, how hard is it to go from a load balance configuration to a more centralized configuration? Like, you said you could automate that, for nighttime versus daytime use?
You mean if you want to go from a load balancer to not using one, or?
Yeah, from yeah.
I suppose, if you were really going to go from a load balancer to not using one, in terms of, because there might be a difference between using a load balancer at all because you want to cut the cost of that
Right.
load balancer, versus only routing to one box. Because load balancer actually probably won't end up being a very big line item, just the use of that service in your bill. But if for some reason you wanted to do that, you'd have to do something with your DNS, because your DNS is going to, if your domain name is mapped to the load balancer, and you want to all of a sudden have it just go to the IP now and bypass the load balancer, you're going to have to play that game, which you can do, and it's scriptable, especially if you're using Route 53, their DNS service, and it's also dead fast. They're almost guaranteed it happens within about 5 minutes. But
You wouldn't recommend that then?
no, I wouldn't. I would just say if you're already at the place that you need a load balancer even throughout the day, then I would just pare it down to where you're still going hitting the load balancer, but it's not balancing anything. It's just going to one. It's just got one server behind it. That will give you the rest of anything else that you're using. But it may be more complex. I'm sure a sysadmin could come up with another scenario, but I would think that would be more tricky. Because in the end, you're definitely routing traffic to that load balancer. And if you want to change that, you've got to change the route. Okay, so right, it helps put the E in the elasticity because it does allow the different EC2 instances behind it. I know we're running a little bit late. I don't want to go through every single bullet point. If people kind of understand why you might use a load balancer in general. But it does, in terms of why would you use something like this, the benefit is that you're really coming at it from not having to know anything about the complexities of how to configure a load balancer, or what sort of even capacity you need to house it. All of that, the whatever software updates and all that kind of stuff is you're kind of offloading that from the service. You can also manage SSL certs across your multiple instances at the ELB level, which is pretty nice. So it's just one place where you've got 50 boxes and you need HTTPS, you're just dealing with that cert at the ELB. Okay, so how do we set one of those up? We're going to go back into EC2, load balances under network security. Obviously, the create load balancer is probably becoming a little old hat. And you give it a name, and you've already told it that you want it to be inside EC2 instead of the virtual private cloud. And then you start to configure a little bit about the protocols that you want to be between the load balancer and the instances, and between the public and the load balancer. So you can choose the TCP and the HTTPS. In this case, we're just going to rock out a single HTTP at port 80. So it also provides a very basic way to know whether the instance behind it is healthy. And you've got a couple options to choose from that. One is just a basic HTTP request at a port to a specific file. And I often just use like a heartbeat.php that just echoes out okay to HTTP 200, whether or not it's there. There are other ways you can configure that if you like. And then you choose the instances that you have that you'd like to be behind that load balancer. In this case, we only have two. We're going to go all in, and it gives you obviously an opportunity to review the stuff. But again, that's all there is to setting up a load balancer now with two boxes behind it.
Does the load balancer give you a static or elastic ID like static, or do
It
you
doesn't.
still-
It gives you a CNAME that you have to map to your domain, and that is not, again, sorry, just real quick, while we're here, you can look at the instances. It tells you whether or not they're healthy or not. And they weren't healthy to begin with because it's just waiting to initialize the configuration. It's just getting it all set up. But otherwise, once it's up and running, as long as the instances are healthy, this will say healthy. If it doesn't get that 200 back or whatever you set up as an instance check, it'll be unhealthy and it'll automatically take it out of the pool for you so your traffic won't be routed there. So you don't have to do anything to get that to happen in terms of that automatically taking it out. Now, you do have to do something if you want to spin something back up in its place, and that's part of the scriptable infrastructure. So the DNS name that comes with that load balancer is right there. And they don't provide a static IP, they provide you that is the A record. So mapping a CNAME to like your zone apex is not something that's officially supported by all DNS houses. So that's one reason why we went to use Route 53 for all of our DNS as well, because it's dead simple. And I don't know what trickery they do to bypass or to get that to work out where it needs to. But basically your zone apex, you're not a www or QA or staging dot whatever, just your main domain name.com. A lot of DNS mapping systems really expect that to be an IP address and not a CNAME. And I think that cloud, is changing now. I think you're going to find quickly that that's no longer going to have to be the case because of just the elastic nature of the changing of the addresses. But it's true, we did go to Route 53, and Route 53 is pretty nice. I don't work for Amazon. It's not like I'm trying to promote their services. It's just been, that particular service has been super nice. Okay. Let's see if this thing goes. All right, so is that all there was to that? Yeah. So we're getting close, almost done. RDS, so now that we have two boxes behind a load balancer, how do we want them to kind of speak to one persistent database storage rather than each of their individual? We did set up the AMP after we got the L going, and that included the MySQL. But there's a couple options that you have. I'm not even trying to say it's exhaustive. There may be a third or fourth, but you can spin up another instance, super dead simple, and just let that be your MySQL instance. You've already got an AMI, it's got MySQL on it. You can just let that be your system of record and go from there. But you can also use, they have another service within the AWS suite called Relational Database Service. So it really makes it very easy to set up MySQL, and they offer a few others, Oracle and SQL Server, and they actually take care of the licensing costs for you, just in the cost of spinning up the RDS instance. And it provides, you're offloading the operations and maintenance of your DB, and it allows you to easily scale your DB. So again, the why, you might, it just depends. I mean, some places are going to have DBAs, and there's DBAs that may or may not want to relinquish, that kind of stuff to a black box. And in some ways, it is a black box. I mean, you get MySQL command line access, but you do not get root or SSH into that instance that's running it. So you can't really jump on your database RDS instance and figure out what's the CPU utilization or any of that kind of stuff. You're left with that being a bit of a problem. On the flip side, you don't have to worry about the capacity for it. That's elastic and can scale up and scale down as you need it. It's going to take care of the software installation. It's going to take care of the backups. It's going to patch the software. It's going to handle the scaling, and it can deal with synchronous data replication across availability zones as well, and manage your automatic failover. So as your needs get complicated and your DBA team's thin, it starts to become a pretty sexy option. But I know it can be.
You can connect to MySQL Workbench pretty easily.
You could, yes you can, yeah. Most of the third-party tools will connect, as long as your port's open and your firewall's configured to allow that. Absolutely, it's the same. It provides you the same access for the most part in terms of MySQL, but not the box.
Not able to configure the MI and IaaS.
You can, yeah, absolutely.
Oh, really? Okay.
You just do it through the GUI, and you do it in a different manner than getting on the box and bimming your card away.
Okay.
Okay, so let's see how we do that real quick. We're finally in a different tab, launch a DB instance, but before we do that, it's a good thing to set up a security group, a little bit similar to your EC2 instances. You want to configure a connection to your DB instance, and you've got some options for that. And what we're going to choose here is really just allow the same, anything that comes from the EC2 security group that we set up, maybe slide 6 or 7, to be the only one that can attach to it. But you can choose, you can set up your IP address and however you like. But it's certainly a decent practice, especially in a production environment, that you only want those instances behind the load balancer to be able to connect to it. You'd need to jump on one of those instances if you wanted to access it, but you can certainly put in your IP or suite of IPs if you need access outside of the EC2 security group for whatever reason. And is that all I did there? No, I'm doing something else. Oh, actually launching the instance, that would make sense. So after we get the security group configured, it's just a matter of going in, choosing the engine that you want, in this case MySQL, and then you've got a lot of choices here, the version, the instance class, again, they kind of go along the same tier as your EC2 instances, so it goes from small to real big. The multiple AZ deployment means that it's going to take care of replication automatically for you. If you want that, it's more money, but you can do that. That's a multi-zone deployment. You do need to tell sort of the storage capacity that you need. You want to provide an identifier for this instance. So in this case, it's another dev VB and the date. Very similar to the way that we named the EC2 instance. And then you put in a master username, master password, and click create. You give it a database name, whatever you want that database to be. And any of these other things you might want to change. So again, you can choose the availability zones in a similar way that you do with EC2 instances, and a little bit more information about your backup. Whether you want it to do it within a particular window, whether you don't care in terms of when it does the backups for you. You can figure all that later too. You don't have to do it all Wizard. It spins up similarly to the EC2 instance. It goes through its life cycle and kind of pending, going through status checks, and eventually becoming available for us to use. So in this case, we're going to get that endpoint, which is the host to connect to. And this toggle over to the command line. Now we're on the EC2 instance. So we logged in that SSH with that PIN that I could have shown in the slide but didn't show in the command line. And then just type in all that information we just fed into it in terms of your user and password. And this is basically the access that you get to the box, MySQL box, from an EC2 instance, because we set it up that way. Okay, I think I've actually talked a lot about this already when we were sort of waiting for the connector at the beginning of this, but just in terms of the elastic nature of the cloud is kind of getting your head around that, and building for that is going to really drive the most benefit that you're going to get out of trying to use this setup. So, there can be cost savings, there can be other benefits, but they're not immediately realized. So I think maybe much like people jump to think like, oh, I'll just offshore my development. It's going to be super cheap and it's going to be awesome. It takes a long time to get that right. And so trying to come at this from just like a cost savings perspective can end up being potentially a little bit disappointing. Though you can absolutely see some of that in a number of ways that we talked about. So it's not so much about just the mapping of how much is this server per month compared to how much am I paying over this physical one per month. It's about the elastic nature. It's about the investment that you don't have to make, and about the ability to really craft your infrastructure and massage it and continue to let it be flexible to your needs. So whatever your needs are, your traffic, or your internal needs or your deployment needs or whatever. So that's what's going to drive the most value. And then to the point that some of you made. The other thing to keep in mind as you're architecting, if you go this route, is to absolutely stay super pessimistic about things failing. And you want to make sure that you've crafted your automation and chosen the right disaster recovery options, because things will fail and you're going to be okay with that because it's going to keep going because you set it up to keep going. You won't be so disappointed. All right, let's see. I mean, we've talked about all this at the beginning, actually. It's kind of a recap. So we can